For this video, we're going to talk about something called direct translation, and this is going to kind of be the start of a long journey of word problems or problem solving, okay? So direct translation is the process of converting words to math. That's a very generic definition, but ultimately you're taking some sentence or some paragraph, you're pulling out the important information, and you're creating an algebraic expression or an equation out of that information. And our goal, this is super important, our goal is always to assign the variable to some unknown value, okay? Now, this table right here is something that you need to study independently. It is a table that gives different words or phrases that would indicate addition, subtraction, multiplication, division, and equals, okay? So you don't have to memorize the table, but just familiarize yourself with words that would indicate these different operations or that would indicate equality, okay? So let's go ahead and dive into some examples. So example 4 that goes with topic 4 says translate each statement into an algebraic expression. So we're not going to have any equals here. And then we're going to use x to represent the variable. So let's look at part A. So part A, right off the bat, I see the word product. So we have the product of 5 and a number. Product means multiply. We can also see a number here. That's the unknown value. We don't know what this number is. We're going to call it x. So basically, we want the product of 5 and some number x. So we would just write that as 5 times x. Now, when you're multiplying a number and a variable, you don't have to put a multiplication symbol in between them. Writing 5 beside x in algebra, just automatically the multiplication is assumed. Okay? So part B, we have the sum. So sum would indicate addition. Okay? And for that sum, we want twice a number and 11. Well, twice is multiplying something by 2. So we have some number. We don't know what it is. We're going to call it x. What we do know is we want twice that. So we want 2 times x. And then we want the sum of 2 times x and 11. Sum means add. So we ultimately just want 2x plus 11. Okay? Now for part C, we have double a number. Anytime you're doubling something, you're multiplying it by 2. We don't know what the number is. We're going to call it x. So double a number means 2 times x. And then we want that to be decreased by 7. So we want to take 2x and decrease it by 7. Decrease means subtract. Be very, very careful with subtraction because order does matter. And to figure out the order, you just have to read the question very, very carefully. Here we want double a number, and we want that to be decreased by 7. So 2x minus 7. And let's compare that to part D, because part D is a little different. So for part D, we want 3 times a number. Well, that number, we don't know what it is. We're going to call it x. But 3 times that number is very just explicitly 3 times x. But we want that subtracted from 15. So we want to start with 15. And from 15, we want to subtract 3 times some number x. So be especially cautious with examples like C and D because you're dealing with subtraction and order absolutely matters. Okay? Now for part E, we're dealing with a quotient. Quotient is the answer to division, so we're going to be dividing something. And when you're in algebra, when you start dividing in algebra, you almost always represent it as a fraction. Okay? So you're not going to use the little division symbol where you have a dot, a line, and a dot. You're going to use fraction notation here. So we want the quotient of a number, we're going to call that x, and 4. Now, when you're dealing with a quotient, order also matters, but it's a little bit more straightforward. When you're dealing with a quotient, it's always going to be the first thing they list is the numerator. The second thing that's listed is the denominator. So here we want the quotient of a number, x, and 4. So we would write that as x over 4. And then we want to take that quotient and increase it by 8. So increase would mean add. So we're going to take x over 4 and we're going to add 8. So again, what you would not do is write this as x divided by 4 plus 8. You wouldn't write it like that at all, okay? So this would be like what not to do. You want to write that quotient of x and 4 as x over 4 in fraction form. Now, example F, I want you to really pay close attention to because F and B, part B here, are very closely related. If you look at them, they look like they're almost the exact problem. So in part B, we had the sum of twice a number and 11. In part F, we have twice the sum of a number and 11. So the things that are different is we have the sum of twice a number versus the sum versus twice the sum of a number. So this is a little bit different. Here we want twice an entire sum. we want 2 times some entire sum. This is where we would use parentheses. So if I say twice a sum or twice a difference or 3 times a difference, 3 times a sum, you're going to have parentheses. So we want twice an entire sum, and we want that sum to be between some number, x, and 11. So we want 2 times parentheses x plus 11. So pay very close, pay very close attention to part C and D. Make sure you understand the order with subtraction, but also pay close attention to parts B and F. They're almost exactly the same. One has parentheses, one does not. So understand the wording there. Now for topic 4, we're also going to look at example 5. So example 5 is very similar, except in this case, we're going to be looking at equations. So example 5 says translate each statement into an equation. Use x to represent the variable. So what you're going to do with these examples is you're going to look for the word or phrase that would indicate equals. Everything before that is going to be the left-hand side of your equation. Everything after that word or phrase is going to be the right-hand side of your equation. So let's look at part A. Part A says we want the sum of a number and 3, and that's going to yields is our equals in this case, -6. So go ahead and write your equals down. Everything before the word yields is going to be the expression that makes up the left-hand side of this equation. So we want the sum, which means add. We want the sum of some number, which is going to be x, and 3. So we want x plus 3. And then that yields -6. So that just means it's equal to -6. All right. Now for part B, we have twice the difference. So notice the wording here. We want twice an entire difference. So we want twice the difference of a number and 1, and it says it is the same as. Is the same as would be equals. So that's where our equals is going to happen. Everything before the phrase is the same as is the left-hand side of the equation. So we want twice a difference, and that difference is going to be between a number and 1. So x minus 1, and that's going to equal 4. So we have twice the difference, so the difference in parentheses of x minus 1, and that equals 4. All right. Finally, part C, it says the quotient of a number and 5 equals -10. This one's as straightforward as it possibly could be. We literally have the word equals here. So everything before the word equals is the left-hand side of the equation. And that is the quotient of a number and 5. So remember, with a quotient, we write it in fraction form and we just go in order. So the first thing they list is the numerator. So we want the quotient of a number x and 5, and we want that to equal -10. Okay, so this is a very gentle entry into the world of problem solving and word problems. And a lot of what we're going to do in this course with problem solving is we're going to take words and convert them to math. So it's really important that you get a nice foundation on this as soon as possible.